Hello, welcome to HB Industrial Logic. Today we're going to learn about the scan cycle in Studio 5000 and the effect it has on your logic. This is an important subject that I don't believe they teach in college. At least when I went to college, nobody taught me anything about this. They did teach a little bit of the scan cycle, but they didn't really go into great depth on it and explain how it can affect your logic. So we're going to look into that today. So let's get started. First, let's explore how the controller scans the ladder logic. The scan cycle starts at the top and it works its way from the left to the right and from top to bottom, just as you would read a book. Next, let's discuss the two types of scan cycles. First, we have a synchronous scan cycle. This scan cycle takes a snapshot of all the input states, updates the input table, and freezes that table as the controller executes the ladder logic, updating the output table based off of the ladder logic. This type of scan cycle is used in RS Logix 500. The last type of scan cycle we're going to discuss is the asynchronous scan cycle, which is what Studio 5000 uses and what we're going to focus on. An asynchronous scan cycle reads the input states dependent on the input's request packet interval, which you can adjust in the module's properties. Unlike synchronous scan cycles, an asynchronous scan cycle doesn't freeze the input tables until the ladder logic has been completely executed. This means an input that is both on rung 0 and rung 100 can be read in different states during the same scan cycle. Having an asynchronous scan cycle has many advantages, such as faster response time, improved efficiency, it's optimized for event-driven tasks, and it has better flexibility. But there are also some disadvantages, such as increased design and code complexity. It's difficult to debug and test, and there's a potential for data inconsistency. Now, in many programs, you'll see many programmers emulate a synchronous scan cycle in an asynchronous program using mapping. We're not going to get into that in this video, but just know that you can emulate a synchronous scan cycle in an asynchronous program. Now that we have discussed the types of scan cycles and how they work, let's demonstrate how this can have an effect on your logic. I have a simple flash timer set up here, and we're just going to use this to simulate an input, either an encoder pulse, a photo eye on a high speed machine. So it's on for 20 milliseconds, off for 20 milliseconds, and here's where we're using that flasher bit, but we're going to call it the photo eye. And the first example that we're going to look at here is I have this add instruction and a module instruction. And basically, let's just think of this as like a conveyor system, and we have a photo eye that when a package goes by, it loads the data into an array, and the array is 50 long. You have a 50 long array, and it's loading into this, but you need to be able to keep the position and know what position you're on for the next package and so on, and then you can pass it to other sections of the machine so they know where in that array to get that package detail whenever that package passes a photo eye or something down the line. What we have here is just we're adding one to the position. This is our tracker to figure out where we're loading this into the array. And the module instruction, we can discuss a little more in depth in other videos on how it works. But the way this is set up is once it hits, it's never going to exceed 50. Once it gets to 50, it's going to reset and just keep you 0 to 50 in this position counter. So that way you never go above what the array is. We're going to ignore this last section here, so I'm just going to create an AFI so it doesn't run. All right, so let's go ahead and start this. and we're going to trend the position tag. We're going to set up our chart here. If you don't know how to set up a trend chart, I have a video. Just go watch that and it'll explain how to set all this up. All right, so let's go ahead and start this. All right, so you'll see that this position tag, let me change the color of this so it's easier to see. This position tag goes up to 49 and then it goes back down to 0. Let's make one little change in here. We're just going to change the position of the module and the add instruction. And let's go ahead, start our trend again. Start this. All right, so now it goes all the way up to 50 and then it starts off at 1. By changing the orientation of these two instructions, we change which bit in the array is not utilized. It is being utilized to look at with this position pointer. And that is important because what if you're using that one position in the array as just a temporary holder for the package data before it hits the photo eye? As the package is going down the line and certain things are happening, you're loading all that information about that package in this position on the array. And then once it hits the photo eye, you have all the data and you're passing it on. And that's the position that you actually want to pay attention to. Well, if you change the orientation of these two and you're loading that data into slot 0, but you have the orientation wrong, as we just did on here, you see that we always overwrite slot 0 and your data is going to be overwritten with the temporary data. So you're not actually storing your data in the array properly. You're going to lose a package in the process. So why is this happening? Let's take a look. Scan cycle goes from left to right, top to bottom. So when the position tag hits 50, it puts 0 into the position tag because of the way the module works. Then it adds 1 to the position tag, so you always skip position 0. You always start at position 1 and go all the way to 50. But when we switch these two instructions, we'll come over, and when the position tag is on 49, we're going to add 1 to it, which will make it 50. Then it'll come here, it'll go straight to 0. So you only see 0 to 49. You won't see 50. Let's take a look at another example. All right, so we're still using the flash timer as like a photo eye, and we're activating a coil. And we're counting how many times this coil has been activated. So let's go ahead and start this program. And as you can see, as this is going on, our counter is incrementing and the coil is flashing. But let's make a little change. Let's just change the position of these two rungs. And we're going to clear our counter. We'll just unlatch this bit. And let's start it. All right. So now we're running. Our flash timer is still turning on and off, but our counter isn't incrementing at all. And we can verify that this coil bit is actually toggling by trending it. And as you can see, it is turning on and off. But the counter isn't incrementing. So let's take a look at what's happening here. Once we start this flash timer. We'll say after the 200 milliseconds, now it's done. Let's go ahead and go down the logic. Flash timer is done, so we go ahead and latch this bit. We come up here while the flash timer is done, so it goes through, starts flash timer 2, but then unlatches the coil bit. And then by the time we get here, it's unlatched, so you're not counting. So even though this is incrementing and you can see that it is turning on and off, by the time the scan gets to rung 3, the coil bit is already back off. So it never registers this rung as true. So therefore, your counter will never go or never increment. So we can fix this by just changing these two rungs. And then let's take a look at it again. And now you can see that the counter is working. So why does it work here, but it doesn't work the other orientation that we had? Well, let's take a look. When you start this, the flash timer starts going. Let's say that the timer is done. So then we get down to rung 2 from left to right. It is done. It starts flash timer 2. It unlatches the coil bit. Then we come down to rung 4. The timer is done. It latches the coil bit. Eventually, through the scan process, flash timer 2 will be completed, and this bit will open, which will reset your flash timer done bit. So then it'll go through here, it will start the flash timer again. The flash timer done bit will not be open. So then when you get down to the coil, it would still be latched from the last iteration. Therefore, it's going to increment the counter. It's not going to latch it again until the flash timer is done, and then it goes ahead and unlatches it. So simply changing the orientation of these two rungs stopped this logic from working properly. There are other ways to fix this. Let's take a look at one other way that we could have done to fix this. Let's move this back up here. Go ahead and reset our counter just so it's easier to see. As you can see, the program is running, but the counter isn't actually working. We know that switching rung 0 and 1 is going to make this work, but if we also switch rung 3 and 4, you can see that that also will get it to work. So this demonstrates the purpose of understanding the scan cycle when you're designing your ladder logic. Because even though the ladder logic is right and it makes logical sense, the order of it will determine if it's going to work or not. If you have an understanding of the scan cycle, you'll be able to look through and understand why something is working or if something won't work in that orientation. So sometimes it's not your logic that's wrong, it's just the order that you have it in that it makes it wrong. I hope this video helps. If you have any questions, just leave a comment and I will try to address them in future videos. Thank you for watching. Have a good day.